Section 8.4, we're going to look at some special parallelograms, a rhombus, rectangle, and squares. So we're going to understand the difference between these special parallelograms and their properties, and we're also going to solve problems using their special properties. So let's first talk about parallelograms. Remember, these are all the ways to tell if a quadrilateral is a parallelogram. So we could show that both pairs of opposite sides are parallel, and that is by definition. Or we can show that both pairs of opposite sides are congruent. Or we can show the opposite angles are congruent, or that one pair of opposite sides are congruent and parallel. And then also we show that the diagonals bisect each other. That's another way to prove. So remember, once we use one of these methods to prove that it's a parallelogram, then all of those other properties are true about it. So keep that in mind, because a rhombus is a special parallelogram with four congruent sides. So it's going to still have all of the properties of parallelograms. It's going to, because it has a parallelogram, you know that you have both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. It just happens to be that they're all four the same, and that's what makes a rhombus. But remember, both pairs of opposite angles are congruent, okay? All of those things apply. All of the parallelogram properties apply. So again, those are all things you have to keep in mind. And remember, the other thing about it is the diagonals right here bisect each other. So this piece and this piece would be the same, and this piece and this piece. So same is true for a rectangle. A rectangle is a parallelogram with four right angles. So again, all of those same things hold true for every single parallelogram. So again, you have both pairs of opposite sides parallel, you have opposite angles congruent, you have diagonals bisecting each other, you have opposite sides are congruent as well. So what are some of the properties or features of these? Well, a parallelogram is a rhombus. So it's a parallelogram, and it's going to be a rhombus if and only if the diagonals are perpendicular. So now when we look at these diagonals, they are perpendicular to each other. And the diagonals actually bisect those opposite angles. So when you look at these angles, they're bisected. Okay, so then let's move on to a rectangle. A rectangle is a parallelogram. So a parallelogram will be a rectangle if and only if the diagonals are congruent. So not only are the diagonals bisecting each other, but they're congruent. And again, we've said it's a parallelogram. A rectangle is a parallelogram. So all of the properties of parallelogram apply to rectangle and apply to rhombus. So our third one is a square. And a square is really a hybrid between a rhombus and a rectangle, meaning it's both a rhombus and a rectangle. So that means that all the sides will be congruent. That's the rhombus feature. And all the angles are right angles, and that is the rectangle feature. So again, now all of those properties that we just talked about for rhombus and for rectangles apply. And here's kind of a way to look at it with a Venn diagram, that when we look at all parallelograms, we have some special parallelograms are rhombus and some are rectangle, but the crossover, the square, is both the rhombus and a rectangle. So for any rhombus, A, B, C, D, it's telling you that it's a rhombus. Decide whether the statement is always true or sometimes true. So in a rhombus, will angle D and angle B always be congruent? Or only sometimes? Well, this is always, because it's a parallelogram. And every parallelogram has opposite angles congruent. What about the second piece? Will AC be congruent to BD? Well, here's your diagonals. Will they be congruent? Well, a rhombus does not necessarily have congruent diagonals. It has diagonals bisected to each other and perpendicular. But they're not necessarily equal to each other. That's sometimes, and that's sometimes if it happens to be a square. All right. So now let's look at this rectangle. For any rectangle WXYZ, decide whether the statement is always true or sometimes true. So will WX right here be congruent to YZ? Yes, that will always be true. Why? Because it's a parallelogram, and in a parallelogram, both pairs of opposite sides are congruent. So always, because it's a parallelogram. So how about the next piece? Will WY be perpendicular to XZ? Will this be perpendicular? Well, not necessarily, because rectangle, we know that the diagonals bisect each other because it's a parallelogram, but we also know that the diagonals are congruent. So it makes all these pieces the same, but not necessarily a right angle. So this would be sometimes if it's a square. So sometimes it can get confusing. So you really want to understand and learn these properties of each one. Each parallelogram property and all the properties now for square, rectangle, and rhombus. All right, so what if you're given this figure? You don't go by the looks of it. You go by just what is given. So even though it looks like a rectangle, you don't say that until you've actually decided what is the most specific name that you could call this. Well, first of all, I can see that I have opposite angles that are congruent. So that means that it's a parallelogram. I've just proven that it's a parallelogram. Okay, but can you prove anything else? Well, we have 4 right angles. So that means it's a rectangle. And we have the diagonals perpendicular. So that means it's also a rhombus feature. So it's a square. Okay, so we want to give the most specific name possible. And this is the process that I usually use. First I see, can I prove it's a parallelogram? Then, can I prove that it's a rectangle or a rhombus, or both? And if it's both, then it's a square. So let's take a look at this question. It says, will this window frame fit a rectangular window? Okay, well, let's look at this for a minute. Okay, you can see that we have 33 inches by 44 inches by 33 by 44. So we're like, hey, that's one of the features of a rectangle. Because it's a parallelogram, the opposite sides are congruent, so it's a parallelogram. But is it a rectangle? Well, we don't know anything else. What makes it a rectangle? Well, I'm sure when they built this frame, they tried to make 90-degree angles there, which then would say rectangle, but those aren't marked that way. So what you could do is, again, measure all those angles. So are the angles 90 degrees? Well, sometimes even though you make them 90 degrees, they could be slightly off. So how else could you tell? Well, the other way you tell is you measure the diagonals to see if they're congruent. So are the diagonals congruent? Well, when you measure the diagonals and you find that they are 58.8 inches and 55.3 inches, then no, it's not a rectangle. What shape is it? It's a parallelogram. Okay.